And that should be live. Waiting for it to show up on the channel. There it goes. All right, awesome. Welcome everybody to GCP Online Meetup number 62. Today we're going to be talking about Terraform. I'm your lovely host as always, Mark Mirchandani, customer engineer here at Google. And we've brought along a few friends to help us kind of talk, but I'll let them go ahead and introduce themselves.
Hi, I'm Nick Williver, engineering manager at New Context.
And I am Aaron Lane. I'm a senior DevOps engineer at New Context.
Awesome. So I guess first thing is, kind of give me a good idea of what New Context does.
Sure, I can do that. New Context is a lean security company that automates the orchestration, governance, and protection of critical infrastructure and the industrial internet. We do DevOps consulting, work in the open security standards, and are creating products to more effectively understand organizations.
It's kind of a broad scope, but what would you say you mentioned security and government. Would you say those are kind of the primary customers that you work with?
Yeah, there's definitely a lot of different customers we work with, but we try to focus in on being able to protect the critical infrastructure and the industrial internet that's coming about.
Awesome. Well, so today we're going to be talking about Terraform, and I know you've prepared some slides. If you want to go ahead and pull those up, we'll present them to everybody.
Sure, sounds good.
And I'll make sure that this goes out to everybody. Cool. The slide should be up.
Great. I can start.
Please.
All right. Well, we went through us already, so I'll keep going. So as many of you know, software projects take time to mature, community grows around it, and then tooling begins to form. These tools could be methods for sticking to a standard within a project or as a community as a whole. They also start finding ways to distribute their code, create a test framework, and eventually we all try to wrap this up into a CI/CD pipeline. And so HashiCorp has taken the opportunity to create best practices documentation and Terraform module recommendations. And I put those on the slide so you can look at those later. And so those type items greatly reduce the amount of churn in methodologies within the community. HashiCorp also has built a couple of native functions in Terraform, which is help during development and CI/CD, such as the Terraform format and Terraform validate commands. And more recently, they've released Terraform Registry, which is a method of distributing community Terraform modules. And the item that we want to talk to you about today is Aaron and engineers at New Context have created Kitchen Terraform. It's a framework around validating your expectations of a Terraform run, which uses inspect and kitchen.
Okay, so let's take a quick step back actually and
Sure.
talk a little bit about Terraform itself. And for some people who might not be familiar with it, kind of what are the advantages and what are the problems it's trying to solve?
So Terraform is trying to, it's basically infrastructure as code. It enables you to safely and predictably create, change, and improve your infrastructure. So it could be a ton of different cloud providers. In this case, we're working on, or we're going to have some demos on the Google Cloud Platform. And it's an open source tool that is able to take APIs from those infrastructures and make declarative configuration files that can be shared among, as I said, with the Terraform registry, but also shared on different sources that you can pull in from Terraform modules.
Okay, and like you just mentioned, that would work on any kind of infrastructure, regardless of where it was running, right?
Yeah, there's multiple provider plugins for Terraform. So you have most of the major clouds. You have a lot of different things that they have been the community or HashiCorp themselves have been creating for interacting with it. I mean, they go from Google Cloud all the way down to a Google Calendar plugin.
Awesome. And someone asked a question about posting these URLs after the video. Can we share these slides?
Yeah, for sure.
Oh, that'd be great. Okay, we'll post them after the video then.
I'll continue on. Let's start with that screencast. So now, so we're going to take those standards, best practices, and frameworks that I just talked about and put them into use with the Google Cloud Platform. And so in the moment, I'm going to run through a screencast of using multiple Terraform modules within a live repository, and there will be a build of an example application running in production. And to explain the live repository terminology, it's used to distinguish a Git repo that holds all the Terraform code that builds a particular environment. So it takes environment agnostic Terraform modules and puts them to use. Let's start that screencast. Waiting for the YouTube player to start.
So in this case, this screencast is just kind of showing what that looks like and what the steps that somebody might be going through in order to kind of step through the process of creating this infrastructure.
Yeah. Yeah, let me, oh, I can't click present. Why is that?
It looks like you might have hopped offline for a second there.
Okay, let me refresh the page real quick.
Yeah. So while that's going, obviously the whole space of DevOps and CI/CD and a lot of all these tools that are coming out have been pretty hotly contested for a while. Aaron, what might you say are some of the most interesting things that you've seen come out of the kind of the space in the past couple of years, and what makes Terraform the new hotness right now?
I think Terraform is particularly interesting because the way that it's been designed based on the provider system that Nick was alluding to means that we can take the same HashiCorp language, the language you write configuration files in, and you can describe infrastructure across a crazy array of different providers, different platforms, all in the same simple language. You can intermix infrastructure across different providers. So in theory, you could have a single environment that spans Google Cloud and AWS and Azure intermixed just based on your business needs. So it's a really interesting, it's a really powerful kind of abstraction. And it lends itself really well to automation through CI/CD as well, which is always a really great thing to have.
Now, does this kind of integrate with some of the other tools that are being used out there? So like you can spin this up and then use kind of Jenkins to help manage that. Would you put this under, using Spinnaker to actually do the deployment? Which tools does it kind of replace and which ones does it work with the best?
Yeah, so it doesn't necessarily, it wouldn't necessarily replace any tools, but it does complement well systems like Jenkins or Spinnaker. The really nice thing about Terraform is the command line interface. It's really simple for an engineer to use from their local computer. They could manage infrastructure that way, but the commands are the workflow is really straightforward, so that you can easily take those same commands and map them into like an automated continuous integration, continuous deployment pipeline. You can so you could basically have your do pull requests against your infrastructure as code, have your peers review it, everything looks good, sign off, merge that into your master branch, and then that's going to ship out through CI/CD, and you'll just see changes to your infrastructure get pushed out.
Cool. All right, and it looks like maybe Nick has the webcast running back up again.
Yeah, we're back. I took a local call to play it, so I don't know if I'll be able to get back to the Google Slides. It's still saying I was offline. Not sure how I'm doing a Hangout and also being offline, but well, either way, we have a backup. So let's go through
the magic of the internet.
So what we're looking at is the Acme Corporation's Terraform modules, which are currently prefixed as TF module, and the live repository called TF live prod. In the live repository, as I've just shown you, the folders, which are, they pull down a single module for this simple example, the names of those folders match up more or less to the Terraform modules. So you'll see app, and bucket, and so on and so forth. So we will basically each of those folders match to those modules. And now we'll go ahead and go through to initialize the repository from scratch. So no infrastructure has been built yet. And so what we'll first do is go through the README, and we'll initialize the first thing, which is we need a place to hold the Terraform state. So we're going to create a state bucket using Terraform provider. And that state bucket is just going to create a bucket in Google Cloud. And it's going to hold each folder's Terraform state file. So this is a way to initialize a repository and then also be able to collaborate in the future with multiple people, so that you have your state file updated by multiple people in different locations, so that you just don't have a local state file. And so what I'm running now is a Terraform init and update, and then we'll do an apply. And so we're going to build this out in the US West 1A zone. And once it's built, we'll run the apply, and we'll build it, and then we'll be able to change over the Terraform state backend to the bucket that we just created. So we're creating that bucket. It's called TF Live prod state. And once that bucket's created, then I'm going to update the state.tf file to actually use that bucket and provide it with the GCS backend instead. So right now it's local state with the path of terraform.tf state. So now I'm going to change it to backend GCS, and then the bucket name and the prefix. And then I've already set up the rest of the modules to reference this new state bucket. And so this is just a way to initialize, and right now it's copying over the local state to the GCS provider. So that's all finished now. So now it's time to build out our VPC network, which is going to give us private networking needed to be able to deploy servers into the Google Cloud. And you're going to see the same commands running over and over again. It's Terraform init, it's Terraform get and update, and then apply. I like to run these in order each time. It just makes a lot of things easier. But you can also run just Terraform apply if there's no updates. But I just do it this way every single time. So now what we'll see is Terraform outputs that we can reference in other modules, such as the app subnet, DB subnet, and so on and so forth. And then we'll go on to the next one. So we have 3 more servers to do. We have the database server to build out, which will hold the orders of the Acme Corporation's product sales. And when we go ahead and do a Terraform apply, you'll see a database server and what it looks like. There's a couple firewall rules. That's the name of the server, Acme Corp DB. And then at the very end of the apply, we're also going to have Terraform outputs. And the Terraform outputs are going to be the external IP address and the internal IP, which help the app and job server be able to use the internal IP to be able to connect to it later. So let's just jump onto the external IP. Right now I'm using RethinkDB just to see what the web console looks like. And it looks like the database server is up and running. We don't have any tables in there, but at least we know our database server is running. The next server to build up is the job server. And the job server takes orders from the customer product sales and puts them into the database, so the RethinkDB. And so we're going to run a Terraform apply. There's nothing new here. It's just a apply, and we're building out the server. So I do want to check the database console and make sure that the orders table has been created from the job server. And so it can connect, and it looks like we're getting some sales coming in. We got 10 documents coming in, and it's looking all good. So the last thing we need to do is have a way to view it. So you can view it in the RethinkDB if you want, but we made a quick little admin UI, which will basically be able to have a dashboard of orders of each product and revenue coming in. And so we're going to do another apply. And once we do that, we'll be able to have an app server running. And the outputs are similar to a database, which is we'll have an external IP that we can gather, and I can go to the web interface. And this web interface is very simple, just to be able to parse the documents that are in the RethinkDB. So we got Acme Corporation, and we have, I know we have some documents already in there for product sales. Yep. So we have a couple more coming in. And so that all looks good. And we've successfully been able to deploy all the infrastructure to Google Cloud and then build up an app server and have it running with Terraform.
Great. So yeah, there's been some chat in the sidebar here, and I wanted to kind of quickly. Sure. Someone's a fan of RethinkDB, so that's awesome.
Okay. Nice.
Someone else is asking about, are the Terraform API calls the one that's actually spinning up these resources? Are those run in parallel, or are they kind of run consecutively?
I believe there's a default parallelism of, or however you say that, of 10. But I think you should be able to change it too if you want to. So yeah, things are definitely running faster in the screencast than probably normally are. Though Google Cloud is pretty quick, as you saw probably. You'll see the database server and jobs. It boot up in 14 seconds or so. But I did cut a couple things out and make it a little bit faster, so we didn't waste our time just staring at an apply or something like that.
Terraform. The design of Terraform, it builds up a graph of all of the resources within your configuration, and then based on the parallelism that you've requested, it tries to optimize to spin up as many resources currently as possible. But then there'll be the limitations within the graph. If there are dependencies that one thing has to exist before the other, it will have to wait. But it does parallel whenever possible.
Okay, and I assume there's also then a way that you can kind of make sure certain things are consecutive, so certain things don't run until the previous job is finished.
Yeah, if necessary, you can also you can manually kind of pin one resource as a dependency of another. But HashiCorp recommends that in most cases, just let Terraform figure out the graph on its own, because those things can be kind of complex.
Okay. Cool. And then there was, and I guess, Nick, you're going to go ahead and pull up the second screen share if you're able to.
Yep. Yeah.
As long as we're still online. And there's one more question about, and we'll be sharing these slides after the meetup is over, so everyone can kind of take a look through them. There was one question about how this compares to Google Cloud's deployment manager. I don't know, Nick or Aaron, if you guys have had a lot of time to spend in kind of looking at Deployment Manager.
I have not.
Me either.
I think that's probably a pretty complex comparison. I think that there's a lot that would go into looking what the solutions there are. And I think, Deployment Manager was configured with obviously Google Cloud very specifically in mind. Terraform is a little bit more abstracted, but there are probably a good amount of pros and cons that could make this a much longer conversation. So I think for now we'll kind of just focus on Terraform here. But there are a couple of good articles out there that really show what you're going to use Terraform for and what you can use Deployment Manager for. But I know we want to get onto the second screencast, so let's do that.
I see. Okay. Yeah, for sure. So now we're going to go through and change something in Terraform. So we're going to pretend that the application we just built has been running for a while with minimal effort to maintain. We've also added the live repository to a CI/CD toolset, which means any change we make to the Terraform module is automatically applied to the live repository. And the change our organization wants to do in this case is updating the naming standard, which I'm sure many of you have gone through in the past. They're done for various reasons, and usually makes you update the infrastructure you might not have touched for a while or not remember, but it is running and is backed by Terraform code. So let's go through the screencast. All right, so we're going to go into a database folder within the live repository just to show you the name and what we are referencing for the source module. And you'll see it's Acme Corp, and then the source is our GitHub link. And then what we'll need to do is we'll need to go over to the database module. So that's TF module gcloud DB. And for what the naming standard needs to change is a new variable or a new name within the name. So it would be var .region. They want to know if it's in the west or in the east or somewhere else. It'll help know where to locate the servers and for maybe some billing or something like that. So after that, we need to make a Terraform variable. And this Terraform variable, we'll just call it region as we specified in the main.tf. And we'll just create a default or a description set of what this is for. And then since this Terraform module is deploying to US West, we'll just do a default of West already, just so it's easier to continue on with the demo. So now off screen from here, I've done a git commit and I've done a PR and I've pushed to a master branch. And so from there, this is where the CI/CD would come in. And so I want to simulate the CI/CD so I can show it just on the VS Code editor here instead. And so the DB module was updated. We go into that folder. This is what CI/CD would do. We run a Terraform apply. However, since it's running under CI/CD, or we're trying to show that it is, we're not going to interact with it. So we have to do a Terraform apply with a auto approve switch. This just means that it's just going to go run right through the apply. Okay, so let's see here. So it's beginning to apply. Let's go over to our admin UI that we had up earlier and make sure our orders are still coming in. Yep, everything's looking good at the moment. And yep, there's more items coming in. But we have now a data error. All right, so let's go over to the Terraform log and debug this and see what's going on. All right, so we've destroyed some firewalls. All right, that's not good. Okay, no, all right, so we've now destroyed our database server. So that's probably not good. Things are getting destroyed, and now the database server is getting created in a little bit, I hope. So that's good. But to see, okay, so our name change worked, Acme Corp West DB. So the region is in there, new variable. Maybe everything's still okay. Let's reload the admin UI. Maybe since we have the new database IP, everything will be okay. So let's do a reload on it and see what happens. Okay, so 500 error. So clearly this change was not successful, and a small little name change caused this big issue of losing our database server. So maybe if there was a way to validate and test this before this issue came up. And then I'll hand this over to Aaron to discuss more about that.
All right. Do we have the slides back?
Let me check 1 second.
Or alternatively, I can. Oh, Mark, you're muted.
Thank you. Yeah, I'm just talking to myself over here. Okay, well, while we're putting up those slides again, we can certainly share the slides afterwards. But one of the questions here is, can we also share the Terraform scripts? And it looks like these were pulling all from maybe a code demo GitHub repo. Is that correct?
Yeah, that's correct. And I think we can move them over to our open source organization after this.
Okay, awesome. So what we'll try to do is post as much information as we can for everyone to view after this, and hopefully get access to the slides and to the actual Terraform scripts, so you can take a look at those and how they work. One of the other questions that came up was, what can Terraform do without supported APIs for GCP and Azure? And I think if I'm understanding that question correctly, it's basically that Terraform is this abstraction layer that lets you kind of worry about making your infrastructure in a declaration and not having to worry about the specific parts of the actual infrastructure you're pushing this to. But you'll still have to make sure that when you're actually coding for that infrastructure, that the support is in place to deploy that on whatever cloud provider it is, or if it's your local infrastructure. So, maybe you can clarify your question a little bit, but the idea is that you're kind of creating this abstraction of your actual infrastructure and then having it deploy on with the APIs that would be specific to wherever the deployment is.
Yeah, all of the different platform providers available to Terraform, they're all just abstractions over APIs of whatever platform you're wanting to work with. Basically, the only requirements are that the platform has the simple CRUD interface: create, read, update, and destroy. As long as you have those actions available through an API, it's possible to write a provider for it, and then you can manage infrastructure on that platform using Terraform. So there would be some it is a requirement for the engineers writing Terraform code. You do have to have some level of understanding of the platform you're deploying to. I mean, you need to know what resources you're trying to deploy. You need to understand the particular parameters of those. But the real powerful thing is that you're still able to describe all of those different infrastructures across multiple platforms using consistent language and consistent behavior.
Great. Yeah, I think that kind of covers the whole thing, but we'll go ahead and jump back into the slides now for the third screen share.
Yay, we're back.
Yeah, we're back.
Awesome. All right, so now we're going to talk about validating expectations around our Terraform configuration, and we're going to be using a tool called Kitchen Terraform. Kitchen Terraform is an open source tool for testing Terraform configurations. We created Kitchen Terraform because we found as consultants, we wanted to have the same level of confidence in Terraform projects that we were handing off to clients as we did with other configuration management projects. And we knew that the way that we were going to achieve that confidence was through gaining the ability to test the configurations that we were building. Kitchen Terraform it's really an integration of several distinct technologies. We've got Kitchen, which is an infrastructure testing tool. It's maintained by Chef. It's open source. It's also maintained by great community members as well. And it's a interesting. It's a plugin based tool, so it has no opinions around the types of infrastructure you're applying to, or the types of code you're using, or even the type of testing framework. It's a plugin based tool. So you can basically write any kind of plugins to support multiple platforms, multiple testing frameworks. Terraform is the tool that we're already talking about. That's a pretty important part of this one. And the testing framework in particular that Kitchen Terraform uses is called InSpec. It's a compliance testing framework, also maintained by Chef and community members. And so the way that Kitchen Terraform works is that it allows us to manage Terraform state. And it maps the Terraform commands that Nick had demonstrated earlier, as well as InSpec commands, to the Kitchen workflow, which is a simple create, converge, verify, and destroy lifecycle. And our project is hosted on GitHub under the new Context open source organization if people are interested in taking a look or contributing. So we can start the screencast. So we're going to look at how we can use Kitchen Terraform to test out changes to our database module and hopefully prevent against a breakage like the one that Nick just demonstrated. So first, I'll just give a quick overview of what this database Terraform module is. We've got a compute resource, Google Cloud Compute resource that hosts our database server. And then we just have a couple of firewall rules, one that allows us SSH ingress for engineers, and similarly, one that allows our UI interface also for those same engineers. So the way that we're going to test this is we're actually going to create a fixture Terraform module. This is something that will just invoke our Terraform module. This sets up some configuration for Terraform and providers as per HashiCorp recommendations. And then it invokes the module from the root of our project, the actual database module. And we'll just of note here that we're using a random element in the naming schemes here. And what that allows for us is to be able to run this test suite concurrently across multiple development machines and also in CI without having any naming conflicts on the platforms. So to test with Kitchen Terraform, we need a Kitchen configuration file, which lives in the root of the project. And this just sets up configuration for the different plugins that we're working with in Kitchen. So you've got a driver, provisioner, transport, and verifier. There's also some platform and suite configuration, but those are advanced topics. We're not going to focus on those today. So the driver, provisioner, and verifier are all provided by Kitchen Terraform, whereas the transport is provided by Kitchen itself. So interesting configuration here. We're telling Terraform to test that fixture module I alluded to earlier, and we're setting up some variables to pass into Terraform to help us run. And we're even actually able to do some inline interpolation of shelling out commands to provide dynamic values that we need. So if we execute the first Kitchen action, which is create, this is basically just going to map to a Terraform init command. So it's just going to initialize our test environment, pull in any dependencies that it requires. And that's running again against our fixture module under our test directory. The next Kitchen action, which is Converge, this is the real, the interesting one here. There's a lot done here. So the first thing it does is creates a Terraform workspace. Let's make sure to isolate our changes away from any possible real Terraform state. We update any modules, and then we run through validations as well to make sure there's no syntax errors, anything like that, and see that our variables were successfully interpolated and passed along. And then it runs through Terraform apply, which is, again, the command that Nick has been showing us earlier. In this case, I'd already created the instructor ahead of time just to save us some time. But we can see that everything has been set up successfully, so we have a test instance now. So now we're going to look at the inspect controls. These are how we're actually going to validate our infrastructure. These are all written in Ruby. And what inspect controls allow us to do is basically just describe different elements of our infrastructure and then just make some assertions around their behavior and their characteristics. So in this case, I've got a control for the instances in our environment. We're describing the database instance. We set up a subject for the test. In this case, we're just testing output from the gcloud command line interface. And then we just have various assertions around the data that command line interface provides us, that basically describing the state of our actual infrastructure. Similarly, we have some controls around the firewall rules as well. You can see that we're doing a bit of interpolation there with some attributes defined at the top. And these are actually just a straight mapping of output values that are provided by Terraform. And that just allows us to leverage some dynamic values that we need in order to successfully connect these controls into our live infrastructure. So if we wanted to create a test to make sure that nobody breaks the database naming scheme again and subsequently breaks all of our infrastructure, we can just describe that, saying that our database should be named with provided name in the region. And then again, we're going to do an expectation on the output of our gcloud command line query. And we just want to say that the name of our database instance should match our naming scheme organization. And we're putting in region and then the specifier of database. And so what this will do now, when we run our next Kitchen action, which is verify, Kitchen Terraform is going to invoke the inspect test runner. And inspect is just going to run through all of the specifications in our test file. It takes a bit to load because it's a lot to compute right here. But essentially, it's just going to run through each of our specifications and make the assertion from what we're expecting to see against what we actually get from the gcloud command line interface. And in this case, we can see that everything came back successfully. All these tests were executed on our local machine. And we see there at the top that our new control that we specified was successful. So we know at the moment that our configuration is naming the database correctly. So just to show off kind of the prove that our tests work and that this would help us prevent shipping broken code through CI/CD. We're going to go and add some important additional business information to our naming scheme again. And now when we reconverge our Terraform structure, similar to what Nick showed us earlier, again, as expected, we see that our structure is being destroyed and recreated. The reason being that because we've changed the name of the database instances, Terraform decides we need a new instance to match that name, and so it destroys what was there and creates a new one. This is a nice advantage of working with Kitchen Terraform, is that you can kind of bring up a Terraform environment, make some changes, play around with your configuration, and you can keep reapplying it to this isolated test environment and seeing the kind of impacts that it's going to have on your infrastructure. So we can see now that Terraform is basically recreating another database with some more firewall rules. I wasn't as clever as Nick, and I didn't cut this out, but it comes back pretty quickly because, again, Google Cloud is a pretty fast platform. So if we run the verify command again now, again, inspec is just running through all of those test cases that we outlined against the output of the G Cloud interface. And this time we see that we got a failure because somebody has gone and changed the naming scheme of our database again. So this, if we had pushed this through CI, we would have prevented this module from ever being shipped and subsequently picked up by our live repository. And thus we would be preventing unexpected breakages. So we'll switch that back just to make things happy, reconverge. But this isn't the only kind of test we can do with Kitchen Terraform. We can actually write controls that will be executed on remote machines in the infrastructure, so not just from localhost. So in this case, we're just going to demonstrate a simple control that makes an assertion around the metadata provider within Google Cloud Platform. So we're just going to make a simple test that says our database instance should be tagged as a database. So we're just going to run a curl command to query the Google metadata provider. And again, this command, the expectation is we're going to run this command on the server, not from our local host. There's our URL to tags. And so we're going to assert that our instance should be tagged with DB. And so we expect the output from our curl command. We have to account for string encoding just because it's fun working with computers. And so we just expect that our tags are going to include the tag DB. Now, in order to run this control on the live infrastructure rather than from localhost, we need to make an adjustment to our kitchen configuration. So we still have this local group of controls we're going to run, but we need to explicitly specify that we only want that to include the instances and firewall rules controls, which we've already demonstrated earlier. And now we're going to add a second group to this verify configuration for our remote controls. And this will specify that we only want to run our metadata control. And in order to run this on our remote machine, we're going to need to specify the host names that we expect this to run on. And the way we obtain that is through a Terraform output, which we'll define in a minute. We need to specify an SSH key in order for us to successfully connect over SSH to the machine. This is a file we use to provision the test environment already. And then we just need a username as well. In our case, it's Ubuntu because we're running an Ubuntu server. And so we just need to define our database external IP output on our Terraform fixture module. And then Kitchen Terraform will be able to take the value of this output, which will be the IP address of the external IP address of our database instance. And then it's going to use that value and connect to that address using SSH, and then it will execute our controls on that server. So if we run the verify command once more, or sorry, we have to converge first to make sure that those Terraform outputs are available to us. Just add those to the Terraform state. But now that we run the verify command, so let's see the last time. So again, inspect's going to first run through all of the original controls we had defined, running on localhost. to take a minute to run. And so those are all coming back green. And now we can actually see that the second group that we've defined, our remote group, has also executed. And we can see that it specifies it actually ran on that IP address, the remote host, ran over SSH. And there we have it. So our curl command on the remote machine was also successful. Mark, you are muted again.
No, I caught myself this time, but you still got there first. So one of the one of the things I noticed there with Terraform is it's tearing down and re-putting up these instances as you kind of run and verify the scripts in there. Would you want to be using this on a production workload?
No. So Kitchen Terraform provides a great convenience in order to test Terraform modules in isolated environments. It's nice because it kind of it automates a lot of the Terraform workflow for us in terms of running through our validates and applies and updating modules and things like that. But it also takes great liberties with making destructive changes without any sort of human interaction, which is definitely not something you would want to have happen to your production infrastructure. So I highly recommend for our viewers to never use Kitchen Terraform to manage your production infrastructure. You should only be using it to test in an isolated fashion. You gain that confidence and you know that your module changes are good and valid, and you can ship those out and pull those into your live repo and actually push those changes into production.
Cool. And then we have another question here. We're running a bit over on time, so we'll try to wrap it up. But can we create custom modules on top of these APIs? And I think the answer is of course going to be yes. All of these, all of the Terraform and all of the Kitchen Terraform, all of these are open source, and kind of the idea there is making sure they're extensible as possible, making sure that they can be deployed in as many ways as possible, and kind of making sure that they can fit your use case, whatever that is. I don't know if you have anything to add there.
Yeah, I mean, in terms of Terraform modules, that's completely open. You can define a module that sets up any kind of resources you want based on what needs of your organization. There's no real limitations there other than the multitude of providers for different infrastructure. In terms of Kitchen Terraform, right now we are limited to supporting the inspec test framework. But we do have plans in the future to try to open that up so that people can pull in different testing frameworks as they would prefer.
Yeah, and all of that's on GitHub, right? So
yes,
if anybody, I'm sure, wants to contribute, I'm sure everyone would be more than welcome to get as much help as they can.
Absolutely. We try to foster a very open and collaborative and supportive community around this project. Dealing with infrastructure stuff like this is a big challenge for a lot of people, so we try to make it as easy and fun as possible.
Absolutely. Great. So yeah, like I said, we're a bit over on time. What we'll do is we'll post the slides, as much information as we can, back to this YouTube link so that people can go back and rewatch it, and they can have access to the demo and the Terraform, the actual Terraform scripts that are running. Nick, do you have anything else you wanted to wrap up with?
No, that's okay. Since we're running out of time, I was going to recap, but I think we all understand what's going on. And also the last slide, we'll put it out there, but we also have other screencasts on Terraform running on Google Cloud with Kitchen Terraform and Inspect. And I would like to say thank you to our company, New Context, for helping us sponsor this project.
Yeah, absolutely. Thanks so much to New Context. And of course, thank you, Aaron and Nick, for kind of coming on and talking about this. Hopefully the people who are interested can kind of dive in and look at some of these open source repos out there and hopefully contribute as well. But I'm sure there'll be a lot of kind of questions coming up about how to use these things and how to best kind of make them work for their work cases. And I'm sure there'll be plenty of development going on in that space as well. So stay tuned. We'll try to put as much information as we can. And of course, we'll always have more and more online meetups to try and cover some of the new and cool technologies. Thanks for joining, everybody. We'll see you soon.
Thank you.